Good day, viewers. In this section, we are going to distinguish between vector and scalar quantities. Here are some typical physical quantities that normally we measure. These are pressure, velocity, mass, speed, acceleration, and so on. Among these physical quantities, there are those that obey normal arithmetic rules. That when you add let's say 3 kilograms plus 4 kilograms, the answer is going to be 7 kilograms. Okay, this is correct in arithmetic. 10 kilograms plus 15 kilograms. This is going to give us 25 kilograms. The answer is independent of who comes first, whether we put 15 first, okay, plus 10. The answer is independent of because this is arithmetically correct, okay. So this kind of physical quantities are normally called scalar quantities because once the value is stated, you have full meaning, you can derive full meaning from the values. Okay, there are other quantities also which are also physical, but they don't obey these rules. Okay, example is a displacement. Let's say you leave your home here, and you travel some 5 kilometers to an ATM machine to collect money. After collecting the money, you come down to, let's say, filling station where you buy some fuel for your vehicle. Then you realize that your displacement, your distance from home is just, let's say here is 4 kilometers from the ATM to the filling station. And after reaching the filling station is just 2 kilometers away from your home. Okay, so if we are talking about displacement, the overall, when you are at the filling station, the overall displacement of you from home is this 2. This is the overall displacement. Okay, and when you return home, the overall displacement can even become 0. Meaning that you are 5 kilometers to the ATM as far as displacement is concerned, plus 4 kilometers from the station. When you add them, they will produce 2 kilometers as the resultant displacement after following the 5 kilometer and 4 kilometers road to the filling station. This is violating arithmetic rules. And this is because we are talking about vector quantities. Displacement is a vector quantity. In fact, sometimes the displacement, you may have 0 displacement, where you can say even 5 kilometers plus another 5 kilometer can give you another 5, can be 5 kilometers again. Let's see this one. It's possible you move 5 kilometers, okay, 5 kilometers. You still again move to another location which is also 5 kilometers. Okay, and coincidentally, your displacement from here to your initial position can also be 5 kilometers. So in this case, 5 kilometers plus 5 kilometers give you 5 kilometers. This is because we are talking about displacement, and displacement is a vector quantity. If you now sum the total displacement of you when you completed your journey, the answer would even be 0. Okay, so these are the differences between scalar quantities and vector quantities. Okay, let's add one more example. It is because of this peculiarity with vector addition that we have to illustrate and remind ourselves about those rules that governs the addition of vector quantities. And this example are as follows. Let's say we have an object O here situated here, and there are two forces F1 and F2 that are pulling the object, and they are applied such that the angle between the two forces is 60 degrees. Okay, the question is we want to find out the resultant force acting on the object due to the two forces. So let's assume that this force is 15 Newton and this F2 is just 10 Newton. Okay, so for us to find out the final resultant force due to these two forces, we have to obey some rules. The first rule I want to intimate to you is what is called head-to-tail arrangement. Head-tail arrangement. Head-to-tail arrangement. Okay. Head-to-tail arrangement. What it means is that when you look at these two vectors, two forces, this is the head of 15, this is the head of 15, and this is the tail of the 10, the head of the 10, and this is the tail of the 10, and this is the tail of the 15. Meaning that in this case, the two forces are arranged tail-tail. The tails are connected. Okay, so this arrangement will not help us to evaluate the final result. So we have to make some corrections in the arrangement so that we can resolve the two forces to find the final one, which is the resultant. So the resultant can be obtained this way. Let's divide this here. Let's move the forces here. Okay, let's say they are here. They are here. Then we have to pull down our 10 Newton here so that this 10 is now here. We are bringing the head of 10 to the tail of the 15. So this is our 15. So in this arrangement, they are in head-to-tail arrangement. Head-to-tail arrangement. So when we do that successfully, our resultant is just this third one. Okay, this third one is our resultant. So what remains is to find out the angle. So we have a triangle here. We have a triangle here. Having this triangle, we will now apply some rules that govern the geometry of triangle. We will use some rules to evaluate our R. So let's clean up this side and try to apply the rules. Okay. So the two rules are, these are the two rules. One, sine rule. Sine rule, which we can remind ourselves about the sine rule by taking any arbitrary triangle with angle A, B, and C. Okay, this is angle C. And the side facing C is small c, side facing A is small a, side facing B is our small b. The distance from here to here is B. The angle here is C. The distance from here to here is small a, and this is our angle B, and this is our angle angle A. So our sine rule states that our distance A over sine A angle A, sine angle A is equivalent to the distance B over sine B, and this is also the same as the distance C over sine angle C. Okay, this is the first rule. The second rule is the cosine rule. Cosine rule, which is saying that for each angle here we have a cos. So cosine of A is going to be the two sides that form the A. B square minus C square plus C square, minus A square is all over 2 times B times C. Cos this is cos A, and cos V is going to be the two sides that form the B, we add them. So it's A square plus C square minus B square all over 2 times A times C. And finally cos C is going to be A square plus B square minus C square all over 2 times A times B. So if we employ this rule, in our question, we can be able to solve our problem. So let's clean off this side and bring our problem. So this is our problem. We have 15 here, we have 10 here. This is 15 Newton. This is 10 Newton, and we extended this 10 here, and we know our angle here is 60 degree. So we extended 10 here, and our resultant turned out to be, let me change the marker. This is our resultant R. This is our resultant, okay, R. Okay, so we have to use our geometry to find out this angle. Okay, these are our three triangles. This is our A, this angle is our B, and this angle is our C. So if we look at this angle is a straight angle, and we know its value is 180. So we take out 60, so the remaining angle here can easily be seen to be 120 degree, this angle. Okay, so our B is 120. So we can quickly write our formula for cos B. So cos B is going to be our the sides that form B. This is our 10, don't forget. It is 10 square plus our 15 square minus the side facing the angle, which is R square, divided by 2 times 10 times 15, the one we added. Okay, you can easily see that our unknown here is only R, since we know our B is 120. So the issue now becomes a computation now. We just calculate now. We cross multiply here and solve for R. Cross multiply will give us 2 times 10 times 15 times cos 120, and this is equals to our 10 square plus 15 square minus r square. Okay, if we simplify this equation, we solve for r, we try to make r squared the subject of the formula. It is negative here, so we can bring it here to become positive and move this to the right hand side, so they also become negative. So our final result will now be, let's clean off. Okay, the clean up version is going to be this. So r square is going to be 100 plus our 225 minus 300 times cosine of 120. And if we evaluate the cosine of 120, we are going to get minus 0.5. So a small caveat here, it is important to know that our mode in our calculator should be in deg. To get this as our 0 minus 0.5, our mode should be in degree. If our calculator is not in this mode, we will not get minus 0.5. So you check your calculator whether it is in degree mode or radian mode or gradient. So you make sure that it is in degree mode. So evaluating this, the minus and minus here can cancel to give us 150, and when we add them up, we are going to get 475 as our r square, and taking square root of both sides will give us this amount as our final result. So our resultant of our 15 Newton force and 10 Newton force acting at 60 degree is going to be 21.79 Newton. So this is the final result. So thank you very much. We'll meet in the next example.